Draft physics video. One of the overview style videos, I think, but not with a specific direction intended or in mind. Just sort of a conversation about even how to have the conversation about the fact that perhaps physics has some wrong assumptions built in to their diagram or model of the universe, and that it is possible that they've missed a few things. So this whole project is kind of difficult because the universe gets very small. The real universe, I would argue, is the nuclear universe. The subatomic universe is where the real stuff is moving, and we're just a byproduct of the nuclear function. The chemistry is all really nuclear chemistry, and the big effects of chemistry are again just a byproduct of what happens on the nuclear level. Nothing happens without the little tiniest bits in the universe making it happen. They're flowing and moving in constraints of the structure of the universe. There's little, just as your arteries and your veins carry blood, and then the capillaries, and it's all these little river systems. The nuclear world has its same kind of constraints and the same kind of mechanisms of order and structure that gets built around these mechanisms of between matter and force and how they interact. So there's lots of analogies, I suppose, to what this is. This is like a puzzle with lots of pieces, and they're all cut exactly the same, and the only thing you have to go on is the image on the pieces, because all the pieces are the same. and it's not a very high resolution image, and it takes some work to tell exactly what's it an image of, and it's just it's connect the dots, and there's lots of dots, and there's lots of noise and lots of ways to get distracted and to go the wrong way. There's lots of opportunity to make mistakes because, again, we can't see what's happening. We can't see the rivers and the tides and the structure on the very small level. We can only deduce based on pieces of evidence what might be happening. And so there's certain things we can find out as facts. We can do tests to test gravity and see how it works, and that it's always reliable and it does specific things. And we can play with these other things like photons and magnetism, and we can develop some rules, some understanding of the rules of how they function, and we can find things that are common between them. So I would sort of argue that one of the initial mistakes, Maxwell did some very good work of figuring out the relationship between magnetism and electricity. And again, I would argue that electricity isn't really a force, that it's a byproduct of magnetism when it's really understood on the nuclear level. It's just a manifestation, it's another form or byproduct of the fact that there is this thing called charge, and its charge in different forms create different manifestations. So charge in one expression would be what we would call electricity, which is the movement of electrons, and in another form it's the magnetism that's actually moving the little bits. But what Maxwell noticed was this similarity that electricity and then magnetism, the stuff has a force mechanism that moves the same speed, and it's the same speed as light. And then later or even earlier, they figured out that gravity probably also moves at this speed, because the math comes out better. If you bend space at this speed, the math works better. So it's pretty clear that speed is, again, related. So this was, in my opinion, a huge fact to anybody seeking to unify, that you should find something in common between these photons, the electromagnetic spectrum, all the stuff moving the speed of light that we deal with in terms of the stuff that affects electrons and that we can detect with electron detectors, electron multipliers of one form or another. That's how we detect photons, is that we detect their effect on electrons. Just a fact. We don't really detect photons. We detect their termination in an electron, and the fact that an electron behaves a certain way and then re-emits a new photon, and that's how we detect photons. So we don't see any of them directly. Gravity we detect by how it affects whole material things. So it's affecting protons, electrons, and neutrons. Those are the major constituents anyway, and clearly it has an effect. I don't need to demonstrate it over and over again. And magnetism likewise moves the same speed, does the same thing in the sense that certain matter in certain configurations will create attraction or repulsion. So there's huge similarities in the function in terms of the movement created in subatomic particles, and this fact that there's all the same speed. And I think it was a mistake for physics not to kind of prefer to come up with theories that would respect that similarity and make sure that they don't do something like quantum mechanics and bent space as two explanations for a force that really don't fit at all together well at all, yet the things are moving at the same speed and imply a commonality. It's a rational or reasonable thing to deduce that there is some potential, if they have the same speed, that there's some reason to believe there's might be a preference that this is some kind of common force mechanism, that it isn't being created by completely different things, that it's being created by something quite similar, that a common function. And you really can't make bent space into that. And so I think that's the more broken of the ideas, was to take something that's clearly energetic also. I mean, another fact of these circumstances is that gravity, things moving towards each other, the theory doesn't contain any explanation for where the energy comes from, why the things move. When we know that to move it in any other circumstance, I have to apply force, I have to have rocket engines, I have to have something hit it, matter just doesn't move into each other. And the idea that you're going to create some well or some mechanism that does create this obligation to move towards each other, and yet it's not something where you have to explain where the energy came from. Where's the rocket engine? Where's the fuel? The Earth doesn't burn any fuel. The sun doesn't burn any fuel. How are they creating this mechanism that creates movement without any force? And you can make the same argument for magnetism, that there's no mechanism to explain the energy involved in the fact that things are moving, and there's no force, there's no energy involved, there's no rockets, there's nothing, no mechanism. Now, I would argue that those are glaring defects in the standard physics model, that they don't account for the movement in any of the ways that we know in the real world is required. I have to burn energy to lift this cup. I have to, everything I do, we can account for the forces, because we can account for the cells that are stored energy, and then they burn it, and there's a release of that energy. We have batteries that run everything we own, just about. We're required to account for something. If something's happening, we have to make it happen with energy. And here, two of the biggest things in the universe, gravity and magnetism, two of the biggest phenomena, they have decided we don't need to account for any energy. We don't have to burn anything. We don't have to convert anything. We don't have to do anything at all. We have to just sit back and let them do their thing in some magical way without any energy at all. That's, in my opinion, just a glaring deficit. So combining the fact that the forces all move the speed of light consistently and you know, except silly circumstances like going through mediums, light slows down, but again, the rational argument is the light doesn't slow down, it just takes a longer path to get through the glass or whatever it's moving through. So, and there's another fact that we know with most of these forces, there's this idea that they don't interact with each other, that they radiate something. They create a change in the environment around them, like a magnet, but that you can't make just the forces interact with each other. The force has no ability to push on another force. It has to actually reach a material thing to affect it. And that's sort of found with gravity and other things, that the forces don't, the Earth's gravity doesn't interact with the sun's gravity. The sun creates a circumstance, it affects the earth creates a circumstance, it affects the sun, but the forces themselves don't interact until a material thing gets in the mix. So anyway, these are, in my opinion, strong evidence that having a theory that fundamentally accounts for these things with different mechanisms can't be right. So I would argue that the mechanism of photons is fairly reliable. We sort of understand them in a sense. I wouldn't argue that wave-particle duality is a rational thing to write on one of the puzzle pieces, because it's the fact is that it has dual functions in the sense that it can manifest in a way that can appear wave-like, but so can ocean water. It doesn't mean the ocean water is waving, it just means that there's a reason why it can appear that way. And photons can appear like waves, but they're not doing the same thing ocean water is doing, which is conveying energy through tension. And so this, it's a more complex argument. I've made it previously that tension is critical to the function of waves, and this is another problem with conventional physics, is it doesn't really want to use strict definitions for concepts. So they use a word like wave-particle duality, but they really don't define what waves are very well, or even what particles are very well. So you could argue that Newton's original word, corpuscle, that light was corpuscular, was probably a safer term. Don't bother worrying about what it's made of, steel or jello or whatever. Just worry about the fact that it has a confined and discrete terms to its function, that in most all common cases it's a straight line ray of light. That's why we have the word ray, is because that's the way light functions. It moves in a straight line and it goes from point A to point B in that straight line, and it really doesn't bend or curve or twist or turn unless it hits something, like an electron. And it's a pretty reliable, that part of that model of the spectrum is reliable. But again, the idea of waves comes about because this stuff is in such mass that we think of it as waves, like radio waves coming off of a radio antenna, because there's such a mass of these little bits, and they're regulated in terms of there's a lot of them, then none of them, then a lot of them, then none of them, and that can appear like a wave, but there's no tension between the bits. The bits aren't in any way interacting with each other. They're all individuals going in a direction. The light bulb that's producing this light is being turned on and off at 60 cycles a second. Now, I don't see it waving, but in that sense it's waving, in the sense that it's a bunch of photons, then no photons, then a bunch of photons, then no photons. So I think most people would agree that the photons aren't really waving to me. It's the frequency isn't anything the photons care about. They'd be just as happy not to be turned on and off at 60 cycles a second. And in terms of the power source, the original power. And I suppose that since it's an LED bulb, they aren't. Some of that might be filtered out. Some of that that on-off might be filtered out of the voltage the light bulb is actually running on. But there's probably still some hint of it in there. You could probably detect it if you had an electron multiplier. Call them photon multipliers, but they're really electron multipliers. I could probably detect that little subtle on-off signal still in the light. Now that wave isn't anything like an ocean wave, that frequency, that on-off, on-off. It's just on-off, on-off. It's just a lot of photons, no photons. So there's all kinds of ways to deduce this through, just you think through it and you say, well, what are the important facts here, and what are the counter facts? The things that argue against something. And the idea is to put those together in some sort of rational order that will, when you look at it, it persuades you that certain things can't be the truth. And so, I could say, Little Red Riding Hood pushes electrons. Now, you can figure out reasons why that can't be the truth, because her fingers are too big, and you can make all kinds of arguments saying, well, that can't be the right answer. And that's sort of the objective. And I guess I would argue that it seems that conventional physics doesn't want to go back and have that conversation about any of its assumptions. It just wants to say that we've kind of glued ourselves to these theories and this model, this understanding. We've put the pieces in place, and we really don't care if there's a few of them out of place, because we're just going to force the rest of it to fit together. We'll just create some dark matter and some dark energy and some other mush to make it work. And if something changes, well, then we'll just start hitting the pieces harder with a hammer to force them to fit. And there seems that's kind of obvious that a lot of that's gone on. So anyway, I've pointed out in previous videos that there really wasn't an analysis of the two-slit experiment to see if it could be explained by some other mechanism. Interferometers were told a whole bunch of stuff about what's happening when you split light into, when you beam split it. And yet I've found by doing the experiment that what I was told certainly doesn't meet, isn't consistent with what I observe when I do the experiment. That clearly you can create these elaborate patterns without the need for any idea of photon interference, and that simple things like internal reflections and refractions could explain why there's a pattern. And it just seems like physics hasn't had any desire whatsoever to re-examine or examine at all those previous old, some maybe acceptably described as archaic, kind of in an atmosphere of greater ignorance about the total truth. Again, I wouldn't fault Maxwell for his conclusions, because he had so much less information about the consistency of gravity's motion and even the motion of electrons, what electrons even were, and the idea of being able to compare magnetism, electricity, gravity, and photons. You just didn't have the context maybe to make those comparisons, or to think of those forces as a group of forces, and it's certainly not the atomic forces. So I'm not necessarily faulting the people who came up with these ideas, but it seems that even Einstein's bent space is a 100-year-old idea, and maybe if it was to be proposed today, there would be a lot more scrutiny, because people would maybe appreciate that it seems a completely different foundational mechanism for producing a force that is so much like magnetism, that it has so many things in common with these other elements. Alright, so do I need to say more on that? It's just this idea of how you reach conclusions. Now, I've emphasized that I think much of the evidence for the extraordinary claims of physics, like entanglement, that photons interfere with each other, that they're bent by gravity, lots of these conclusions are based on really, really weak evidence. Not really, like, not a volume of really hard, strong evidence, but just a lot of seems like, looks like, you know, it's got the vague idea of, and, you know, and they're smashing it in too quick, too soon. They're not looking at some other pieces and saying maybe there's a piece that fits that better. They're aggressively confirming the conclusion when the conclusion really isn't. There's not enough evidence for the conviction. So they're convinced, and I would argue that the evidence doesn't justify their confidence and their unwillingness to even consider alternative theories. Now, some of that comes out of the fact that there's a lot of alternative theories. You can make one up every day. I would argue that you can tell the difference between ones that have dealt with the arguments that have been made against certain theories for hundreds of years, and the ones that don't. The ones that just are superficial, and the ones that do get into more, that do attempt to explain more of the observations that have been made and the experiments that have been done, and why they might be consistent or inconsistent with a given theory. So I'm not saying that the atmosphere is so pure that there's a bunch of reasonable people arguing for some better truth. It's like in politics or anything else. There's, every asshole has an opinion, and some of them are, described as garbage, fairly, and that's in its work to have to prove the unfounded nonsense theory does also take some effort, but I still don't think it's an excuse for not admitting that their own foundations are built on really thin evidence that is really indirect, really distant, a far cry from a videotape or fingerprints or DNA. I saw a guy with a mustache, rob the bank, and they're finding the first person that, looks guilty with a mustache. I mean, it's not even close, really, as a contest. So I've gone through some of the Einstein stuff where I've explained that, yes, he answered some questions, but he did it in kind of a sneaky way, because the questions weren't that, let's see what the right word is. They were in the minutia. They were in tiny details. So Newton's original equations for gravity, he basically saw the force as one force, the sun and the earth, and there's one gravity between them. And that was sort of a wrong assumption on Newton's part, that each body creates gravity that it exposes everything else to. So it's almost like they have their own light, so to speak. I mean, you can think of gravity as a reverse light bulb, and each material thing in the universe shines at a certain brightness based on its mass, you could say, and however much brightness there is, that's how much attractiveness is hitting other bodies. So if you just thought as gravity as some kind of light, the metaphor works as long as you think of the light as being something like a tractor beam that pulls things towards it. And that's essentially how gravity functions. And so Newton's model didn't really account for the fact that the Earth and all the other planets were moving the sun all the time. in the sense that they were imposing a gravity back on the sun. Now, it wasn't nearly as strong as the sun's attraction towards the earth, but it's an independent force. Now, Newton accounted for it in the sense that he accounted for it in an equation that combined the two forces and said there's one force. And there really isn't. There's the force the earth applies to the sun, and there's the force the sun applies to the earth. And they're both absorbing acceleration, and that's the real key thing. They're absorbing energy, and by absorbing it, they're denying it from hitting something else, which means it is in a field of imbalance and moves towards it. So it's inductive, like Maxwell had made it. Now, people have often pointed out that Einstein basically just took Maxwell's work and applied it to gravity, and in a sense that's what he did do, in the sense that he accounted for the inductive part of gravity, the fact that it is being induced in the bodies and that it travels the speed of light, and that fixed these irregularities, these little subtle mistakes in Newton's, the imprecision of Newton's math was made more precise with Einstein's math, and yet Einstein did it in a way that's quite convoluted and complex, and he attributed it to a cause that is just synthetic. So the cause, really, his attribution that this is the cause is bent space, is completely unnecessary to do the math. The math is just conceding that the two forces are independently created and that the sun is moving just like the earth is moving, and that movement will change the movement of all the other planets. And that's basically what Einstein figured out, is that the movement, the precession of the sun is going to be felt by Mercury a lot more than it's going to be felt by the Earth or Venus or Saturn or Uranus. So all the other planets, it doesn't really have much of an impact, this little tiny spiraling that the sun is doing off its center of gravity. But it is going to affect Mercury, and that's why Einstein was able to enhance the understanding of predicting the precession of Mercury. So there's all this credit as if he did something outstandingly brilliant, when all he really did, well, the math is really accounting for, is the fact that the sun is precessing, I would argue. I don't think, if somebody wishes to dispute that, I'd be interested in what they think the math is doing. But regardless, the cause part, though, so again, and the simple thing was, as I've pointed out, I mean, the inverse square law, the law that creates Einstein's bent space, Newton knew that. Light bulbs do it. My hand, 4 times smaller here than it is here. Half the distance, 4 times the force. Just creates this well if you just draw it as a well. But there's no reason to think space does that. Space is doing the inverse square law. And you don't have to think of it as being bent. You can think of it as just a force. Like I said, you can just think of it as a light bulb that's turned on. The more mass you have, the more of this attraction radiation you emit. Now, the attraction is really not attraction. As I stated, it's absorption in a direction. So when the Earth moves towards the sun, it's absorbing force to move. It ate the force it took it out of the environment. So the force was hitting, the Earth moves, the force stays inside the Earth. That means it doesn't hit the sun. The sun's getting hit by force from all directions, so the sun moves. When the sun moves, it absorbs force. That force doesn't hit the Earth now, so the Earth moves because there's less pressure. So it's just a pressure, and it perfectly explains it. You don't need to bend space. You just have to suppose that maybe there are photons, pressure, little bits, cosmic background radiation that are always hitting bodies from all directions, and that when two things get within reach of each other, and these forces are all straight line, as pointed out before, the straight lines can't bend around the corners, they can't fill in the gaps, so there's always going to be a shadow cast, just like we can cast shadows on each other. And once that shadow is cast in terms of the force, it will induce acceleration. Things will move into the shadow because there'll be an imbalance of force on their two sides. The wind will be blowing harder from one side than the other side. You can sort of understand that. If you stand next to a building and the wind's coming from the other side of the building, you can understand you're not going to feel the wind. It's it's pretty logical, pretty simple, and it's a perfectly consistent theory with all the stuff we see in the world. Just the simple example of shadows being cast, the simple example of wind being blocked by structures. But there's no parallel example for something like bent space. Nothing else in our real world does any of this bent space thing. So you have a choice to have this pressure field and understand that the pressure can be changed. The light or darkness can be varied based on where things are situated, and that's perfectly consistent with everything we see in the real world. Or you can think, or you can use this other explanation that also explains it, but it's completely inconsistent with anything we ever see anywhere. And bent space is just sitting there glaringly saying this is the wrong answer because it can't work for magnetism and it can't work for the other forces, because the inverse square law isn't a law. Okay, it's a law at distance, but it's not a law up close. And up close, there's the inverse square law breaks down. When objects get close to each other, the force between them doesn't behave the same. It isn't, the spreading doesn't matter anymore because all the force is still going to be hitting each other. So and so you can't, bent space doesn't have an explanation for that. How does bent space modify? Where you can understand that the closer you walk towards the building, the darker the shadowing gets. The less light that gets reflected off other objects, the less it'll get to you. The same argument with the wind, the closer you get. Drafting of two cars, the closer you get to the back of the other car, the more air you'll capture and the less you'll let escape in some inefficient direction. So Einstein's theory doesn't modify to physical circumstances where things can get very close to each other, and there's no longer an inverse square law, and his funnel is no longer the same shape anymore. So lots of reasons to say, no, that just doesn't seem like the right piece. It doesn't fit well, and lots of reasons to think that, well, why not look for an answer that's more like all these physical things we see around us all the time, and that we see heat being like pressure. The more heat there is, the more action, the more banging, the more conflict, the more things are forced apart. And the less conflict and less banging, the more things will fit together. I mean, these are not just intuitive, to us. They're abundant in everything we see that actually physically happens in the environment. Alright. So, we're really just arguing about what's reasonable. This really is a trial. Again, they don't want us... It's like a trial. There's certain rules, where in some cases you say somebody's past behavior isn't relevant or some other thing, and you're not allowed to find out how they treat their neighbors or how many of their pets they molested or some other fact. But clearly what's happening here is there's a whole set of assumptions in physics that they won't let us put them on trial. They won't let us go back to those wrong assumptions and say, let's fix those wrong assumptions before we even have a conversation about what we can prove to be the truth in terms of whether photons can read our minds. And that's how it is that ridiculous. I mean, there's serious physicists who will indulge in conversations about the actual possibility that photons can read our minds, that they know when we're watching them. I mean, it sounds silly, but it's in their own literature and in their own behavior. They like playing with those kinds of notions. as possibilities. And in a sense, that's another one of the counter facts that demonstrates that maybe physics doesn't have much credibility. It's so silly. But anyway, I mean, you're coming to court with a story like that. I mean, whoa. But anyway, so the point is that I'm arguing that if this is put on trial by reasonable people, they can see that yes, maybe mistakes have been made, because the evidence is very obscure. It's all indirect evidence. It's all circumstantial. There's not a whole lot of really solid, hard stuff when it comes to much of the theory of causes behind the motion we see in the material world. And a lot of it is just based, again, on just tiny percentages of the experimental data. I mean, 99% of the experiments say photons move from point A to point B in a straight line and don't do anything else. They don't get bent by magnetism. They don't get bent by any other force except this notion that perhaps gravity, and again, but the evidence is just a tiny bit of evidence, and it's got a bunch of conflicting evidence. The evidence doesn't, the principle isn't validated by the observations. So you have some confirming evidence, but you also have a whole bunch of evidence that points to somebody else must have done it, because the things that should be true aren't true. The things that should be happening aren't happening. And these arguments, again, are just, there's no judge who's going to hear them, is willing to listen to them, is willing to argue, the counter argument, explain why that isn't good evidence of Houston, we have a problem. Physics, you have a model broke. Your model isn't worthy of the confidence you claim to have in it, where you'll say things like it's the most proven theory in the history of mankind. I mean, this is the kind of rhetoric they use for their formulas and their mathematics, as if it has done miracles. And the miracles are like Einstein figuring out that the sun precesses. It's not a miracle, and certainly what they're attributing the cause to is not even, in my opinion, reasonable. So the other thing with Einstein was the fact of gravitational lensing. He claimed it was a possibility now because he dilated time, and the photons would be in the gravity twice as long, and therefore it was a theoretical possibility. And the validation of him was an experiment done 100 years ago with land-based telescopes looking at an eclipse, trying to find a tiny difference in the location of a celestial body. Not exactly hard evidence, and yet the headlines, Einstein was right. Proof, even though it's not proof. And they don't see these as a problem. You point out how it's not a very repeatable experiment, in the sense that every time it's attempted, it's not done any better than it was the first time. The evidence is so bad. And recently we had the best eclipse circumstance you could possibly have, right over North America, perfectly sunny skies, middle of the day, 12 noon. Couldn't ask for a better circumstance, and yet no confirmation still. Yet they'll claim it's proven. You can't argue with it. And again, it's just a bunch of little experiments that indicate it. They'll shoot some radio waves around the sun or something, and they'll get an echo back faster than they expected. But they're radio waves, and they're being diffracted going through the corona of the sun. And so yes, they're getting bent, but they're not getting bent by gravity. They're getting bent by the fog of energy that surrounds the sun, just like your headlights get diffracted by real fog. See, there's real world explanations, there's real world parallels that you can find for all these experiments, and point out how here's a real world explanation, and they just don't even consider those. So this was, it's a very difficult conversation. So I'm just saying all we're trying to do is connect dots, put a puzzle together. And it seems like the people in power, so to speak, they have smashed some pieces together, They're claiming they have it right, that we're not allowed to go back and edit anything they've done previously, and we've got these other 50 pieces that they're pretty confident they can just keep smashing them all together. And I'm saying they're not going to draw a picture of the real universe. They're going to call it a truth, and it's not going to be the truth. And it's going to be the creation of lots of fantasies, you know, like the movie Interstellar, just full of nonsensical, mushy, silly crap. You know, love is now physics. you know, just horrible physics. And that's the picture that physics is creating, and it's just an abstract now. It's just their image of the physical world is so convoluted, it's been hammered into place and smashed together, and it's not a picture of anything. It's going to be more abstract than a Picasso. It's going to be unrecognizable as a model of our physical reality. It already is. You know, all this subatomic particles, the hundreds of the particle soup they've created, little things that last 1/1,000,000th of a second, you know, and they're counting these as real players in the universe because they smashed them into existence. Even that theory alone should be a little bit suspect, but yet they're all convinced. We spent trillions of dollars, well, billions of dollars on it, so it must be brilliant technology. It must be doing brilliant things and coming up with right answers. And there's just no scrutiny at all about exactly what kind of logic the results were put to come to the conclusion. We don't get to see any of the logical deduction, just as we don't get to see the logical deduction for black holes in binary systems colliding into each other and releasing bent space as, you know, 3 solar masses worth of bent space. You know, notions that just don't even, you can't even conceive of what they're talking about. It doesn't make any sense at all, the conversion of matter into bent space. It wasn't even in the rule book, and now they put a puzzle piece in that says that's possible, even though it wasn't an Einstein theory. And yet they'll say it's confirming Einstein. Yet Einstein never said that. Alright, so anyway, I never even got to this image. Well, it's over there. Yeah, there's the image. So anyway, so this is the simple, you know, I'm trying to come up with some way to say this in a simple way, where people just, you know, it's just not that aggressive a statement about how you can understand in this general way the function and then get into the specifics. But I mean, just this general idea of some of what we do know. What I think you can say that even if they call these things different things, you sort of understand that there's two things going on in the world. You know, that magnets don't just magically move, that something makes them move. So anyway, so it comes down to the idea that there's two things in the universe, two ideas you can think about. It's the moving bits, the force bits, and as stated, the photons, you know, the electromagnetic spectrum. So everything in the electromagnetic spectrum, radio waves, microwaves, gamma rays, and visible light, that stuff at a frequency, gravity and magnetism, it's all going the speed of light. So we know all these forces have at least one thing in common. I would say the second thing they have in common is that there's no evidence that these things interfere with each other. We can't bang photons into photons and make them bounce off of each other. We can't bang gravity off of gravity and make something happen. The gravity has to actually reach the other material body. And the same is true with magnetism. The magnetic force doesn't mean anything until there's another material object, especially with magnetism, that can be magnetized for there to be a significant interaction. The polarization the magnet causes can only be read by something also polarized, is the simple statement. And when it can't read the polarization, it just sees it as normal gravity. It just sees it as the force as it comes in two varieties. So the point is there's two kinds of these force. There's polarization in the universe. There's, A and B, black and red, square and round, however you want to define polarization, but there's two kinds of force bits, black and red, and there's two kinds of material bits, electrons and protons. And there's essentially an electron force and there's essentially a proton force. And the electron force affects electrons in a specific way, and the proton force affects electrons in a specific way, in a sense, in a different way, and vice versa. And this, as I've explained on the website, explains magnetism perfectly. It does a fantastic job of explaining why the magnets repel so strongly, because the electrons and the protons are creating reflections instead of absorptions or deflections, and that's all the difference. So the real idea is there's two interactions that can happen in the universe. A thing can hit something and bounce off of it and reflect, and the internal part does the same thing. So these two things hit each other, they reflect, and they go opposite ways. Or things can reflect perpendicular. The blue thing can pick up the red thing's direction, the red thing picks up the blue thing's direction, so they change direction. And that's it. The whole universe can be broken down into those two reactions, and that you change the reactions based on whether electrons are getting hit by the black force or whether a proton's getting hit by the red force. If they're getting hit by black, the opposite force, they'll have the perpendicular reaction, which is essentially lets it loose. Where if they have the reflecting reaction, you could understand that if two things are sitting close to each other and they start reflecting stuff back and forth, that's creating pressure. The closer they are put together, like a little ping pong balls bouncing between them, there'll be more interactions, and interactions are the expression of energy. When one thing hits, encounters, moves towards, however you want to describe it, towards another thing, that's an interaction, that's energy. And that's the realization of pressure, and the whole universe is just a system of being able to moderate pressure. And just like our physical body does the same thing, we have blood pumped by our heart, the pressure is moderated throughout our whole system. There's different velocities and volumes of blood that are moved in different places, and it's all just by regulating pressure. And the universe is doing the same thing. It's just pressure, and the material bits, the force bits can't do anything on their own. Just as pointed out, force can't interact with force. Light can't hit light, light can't hit magnetism, light can't hit gravity. None of the forces can interact with each other. They can only interact with the protons and the electrons, and that's the conduit. The protons and the electrons don't want to do anything in particular, and it's the forces that are pushing them into all kinds of forcing them to move by obliging them to absorb the energy. And that simple mechanism will explain all the phenomena known in the universe. So as pointed out in the drawing here, I don't know if this mouse is going to work, but so you have the force bits, so you could call them E force, electron force, and proton force, two kinds, but they're just little force bits. They move in straight lines at the speed of light, and they account for the photons we interact with in terms of visible light. They account for radio waves, so when they're at a frequency, we call them electromagnetic radiation. When they don't have a frequency and they're not polarized, that's gravity. And when it's polarized but doesn't come at a frequency, it's magnetism. And on the matter side, it's just electrons and protons, and they're attracted and repelled by each other based on how they're associated with each other. And I've explained the different relationships, how you could have two electrons and then a proton in the middle, and how the two electrons could now be closer to each other because the reflecting energy would be going out of the proton, and so there's all kinds of pressure regulation that can happen in mixtures of protons and electrons. Now, the neutron is, I think, kind of understood even by conventional physics to be a proton and an electron in close proximity, and that's what it decays into, so it kind of it seems reasonable to say that must be what it's made out of. If that's what it decays into, a proton and an electron, then probably that's what it's made out of. And so its neutrality is just a circumstance of the fact that it's not really neutral, just like a magnet isn't neutral. It has both poles. You wouldn't call it magnetically neutral, but it's not a monopole. So it doesn't do just one thing. So the neutron isn't really neutral. It's just that it is bipolar, okay, where the electron and the proton are monopoles. So I would argue the electron and the proton are basically the magnetic monopoles. They account for the creation of magnetism, and that seems also so clear, and I don't know why it's a conclusion that regular physics hasn't already drawn, because it seems so, those dots seem so obvious to connect. And also the electrons and protons combined with the neutrons create what we call atoms, and all the properties of the atoms are essentially dictated by how the protons and the electrons are arranged, how many electrons around how many protons and neutrons. And those configurations create the 100 elements in terms of varieties, and the states of those atoms is going to be dictated by how much energy is being pumped into them. So heat and a lot of other things will change those properties quite logically, because they will make the atoms bigger or smaller based on the amount of pressure between the electrons and the protons. There'll be all kinds of expansions and contractions, and higher amounts of attraction and repulsion. So it can all just be broken down into these simple interactions. As the image indicates, a force hits an electron that's black, it just reflects off as what's being demonstrated, and the electron acquires the new momentum. It changes one of its internal elements, essentially, is exchanged. So it has an internal element that's probably going towards the outside. When this one hits, that element changes direction, and now the electron has a bias in terms of its moving in the forward direction. And so the simple illustration of that is two things coming in, hitting each other, they leave. It's a complete 180-degree shift. So this is considered a change in energy. Is when you switch something's direction by 180 degrees, that's an energetic event. That's motion. Then when the red force hits an electron, the reaction is internal in the sense that something moving left to right ends up leaving as the red arrow, and the electron acquires not only a force forward, but because it lost one of its arrows perpendicularly, it now has a bias in a direction, so it leaves in a not a tangential direction. It doesn't leave forward, so it's a less energetic reaction in the sense that the switch in motion isn't 180 degrees. And as illustrated, it's just two things go in, two things leave, and what they've exchanged is their direction. So it's all conservational. One thing goes in, one thing always leaves the system. So and all you're doing is changing the state of the material bit. So the thing comes in, it changes the state of the material bit, and something leaves, pointing out what you've changed. When this reflects back at 180 degrees, it means something inside of this changed 180 degrees, so that this moves. And if it goes in here and something leaves perpendicularly, well, that's a 90-degree change, and it's going to move in a bias based on that change. So you can always call the red force creates a half piece of energy when it hits an electron, and the electron, when it's hit by black, it's a full 180-degree change, so it's a 1 bit of energy. But anyway, you can get into all the details and how the interactions work, and I've done that on the website. So I'm going to put I'm going to make attempt to make new, simpler drawings to attempt to illustrate these things. Just haven't gotten there yet. I think this is the one I'm going to move up. Yeah. Alright, so this is the image on the website. So the one is just pointing out the force is always pushing in from the external world. So all you have to do, the only thing you have to imagine is just as you now can imagine all these photons are hitting you from all kinds of directions, reflecting off of things, and you can imagine that there's all kinds of microwaves hitting you from people's cell phones, and then there's all kinds of Wi-Fi signals hitting you, and then there's radio signals hitting you. There's all kinds of energy hitting you, little bits of straight line force, little rays of stuff are hitting you. The only thing this theory requires you to believe is that gravity is also one of those, that it too is a little invisible force of little bits that are hitting you. And that's all it requires you to do. It doesn't seem a huge stretch to imagine that this force that feels like it's pushing us so hard, and we have to fight against it, because it's hitting us. It feels like that, so why shouldn't it be that? Seems quite logical. So every material little bit, all the way down to the electron, is being bombarded by a pressure all the way around it, and that its interaction with the rest of the universe is going to be based on the fact that if the pressure is compatible pressure or incompatible pressure, I mean, it feels one pressure more than it feels the other, because one goes through it and leaves perpendicularly, and one reflects off of it. So in this image you can't see very well. The electron would be this black object. It has energy pushing out in all directions at the very same time, and the force is pushing in, and they have an equal balance of force. So that's why electrons are all the same size, is because they sort of have to be. The external pressure is one pressure, and they really can't change that any. So their internal pressure always has to be the same to equalize that external pressure, or they would compress, and they don't. And so when you put them in proximity to each other, they'll change their behavior. This is the image just pointing out that as you move two electrons closer to each other, whatever force is trapped between them will be magnified and be at a much higher frequency. Now, as I explained, this is the source of photons. So when photons are released by interactions with electrons, what you're really releasing isn't something inside the electron. You're releasing the force between two different electrons. So the electron the other electron was associated with is the one releasing the energy by compression first, and then releasing it when it rebounds or moves. So the electrons are constantly tied to each other in the sense that they're under repulsive tension. They don't like each other. They're reflecting forces back and forth, so they want to get away from each other, but they also want to get towards protons. There's less pressure between them and protons, so there's a balance between their desire to move towards the proton and the fact that they're in a arrangement around the proton, meaning that the electrons can't move in towards the proton without creating more pressure between their partner electrons. And it's that tension that ends up being vibrated by impacts. So when electrons are hit, it changes the pressure of the system, and the system rebounds, and when it rebounds, it often will let some of this higher pressure photon release in the infrared range or visible range or X-ray range, depending on how much energy you put in. So the more energy you put into the atom, the more energy, in the sense of the higher the frequency that you'll get back out. Now, it isn't more energy, it just means that the separation between the little bits is tighter, and that's why it's blue light instead of red light, or in the case of X-rays, whatever, ultra violet light. But it's that simple. That's the source of photons. It's a perfectly rational, easy to understand idea that these little balls, these little ping pong balls, are hitting us. Just make it a ping pong ball universe, and they're invisible, and they're hitting us constantly, and that you can understand that the key players are these electrons, and that they have little balls bouncing back and forth. They just keep reflecting exactly back at each other, and the closer you bring them together, the more those little balls are going to bounce, which means it's going to be like there's more energy. There's not more energy, there's just going to be like more energy, because there's going to be more impacts, and impacts are where force is realized, is the number of impacts. So this is the diagram of the basic, the idea of the relief valve, the idea that the electron force exits through the proton, and the proton force exits perpendicularly from the electron, and therefore you end up with a low pressure between electrons and protons. And this is the source of the low pressure created by two magnets when their poles are in the opposite position, because all the force ends up leaking out of the alternatively arranged electrons and protons. And so this does explain magnetism very well. It's a basic diagram that the force comes in, if mixed polarization, that is, it's black and red all mixed up together, and it comes out of the magnet, red out of one end, black out of the other end. And ergo, you put two magnets of the same poles facing each other, it's basically just more ping pong balls bouncing back and forth. Repulsion. Have them inverted, the force all leaks out, no pressure, the magnets move together. The external ping pong balls push them together because all the internal ping pong balls are escaping. Perfectly rational explanations, explains the mechanics, explains the movement. This is a little bit inaccurate because it still has a zero graviton, which I don't need anymore. But anyway, I have to fix that. So anyway, so I've been over most of these subjects better than what's on the website, and it's really just a matter of trying to compose this argument. And so maybe I'll try to take some of the structure of this video and try to turn that into a written statement of some kind. But yeah, it is difficult to put into words. I'm not good at technical writing, I find. I'm better at storytelling. But anyway, I think the argument's been made, and I'm surprised at the lack of any kind of reasonable response from so many people in terms of recognizing not only the weakness of the evidence supporting the current theory, but the strength of this as a logical diagram, in terms of it fits what we see, and it fits it so well. So anyway, I think that's enough of a video. So I'll put this image back just for fun. Is this one? Yeah, that's it. Alright, so anyway, so till the next installment, which I guess I'm going to have to keep doing this for some, I mean, frankly, I overestimated the intelligence of the human race, frankly. I didn't think this would take this much effort to get a fair hearing for what I see as such a completely satisfying, in terms of its explaining power and its consistency with the evidence and what we see, theory. This is so simple, and it explains it all. It does what a theory should do of physics. It should be dirt simple, because the universe is dumb. It should be physical, which this is, and mechanically consistent for all the forces and all the things. There should be this common, consistent mechanism. So anyway, so till the next time, and such and so forth and whatnot.